Welcome to Mysterious Universe. Today, we take you on a journey through the vast and awe-inspiring solar system we call home. While it may seem familiar, our solar system is anything but ordinary. It holds stories that stretch back billions of years, secrets hidden in icy belts and distant planets, and mysteries that continue to challenge scientists to this day. Our solar system is just one of over 500 known planetary systems within the Milky Way galaxy. Yet, it remains uniquely special, because it gave rise to us. It's a dynamic system of celestial bodies held together by gravity, orbiting a common center, our Sun. Each world within it tells its own story, with characteristics so distinct they defy expectations. Join us as we explore the history, structure, and remarkable features of this cosmic neighborhood that we are privileged to call our own. 1. The birth of our solar system. Roughly 4.5 billion years ago, in a relatively quiet corner of the Milky Way, a massive cloud of gas and interstellar dust, called a molecular cloud, collapsed under its own gravity. This event was likely triggered by shockwaves from a nearby supernova. The collapsing material began to spin and flatten into a rotating disk known as a solar nebula. At the heart of this spinning disk, pressure and temperature rose until nuclear fusion ignited, giving birth to our Sun. Around it, dust and gas began sticking together, forming small clumps that gradually grew into planets, moons, asteroids, and comets through a process called accretion. This chaotic, high-energy environment laid the foundation for our solar system as we know it today. Today, the solar system is situated in the Orion Arm, or Orion Spur, of the Milky Way galaxy. A minor spiral arm located between the larger Perseus and Sagittarius arms. It orbits the center of the galaxy once every 225 to 250 million years, in what astronomers call a galactic year. 2. The Sun. The star at the center. The Sun comprises more than 99.8% of the total mass of the solar system. It is a nearly perfect sphere of hot plasma, fueled by nuclear fusion that converts hydrogen into helium in its core. This process releases tremendous energy, which radiates outward in the form of light and heat. The Sun's gravity binds the solar system together. It provides the warmth and energy necessary to sustain life on Earth and drives the climate and weather systems of the inner planets. At roughly 27 million degrees Fahrenheit, 15 million degrees Celsius, at its core, the Sun is a constant furnace, emitting solar wind and influencing the orbits and behavior of every object in its domain. 3. Terrestrial planets, the rocky inner worlds. Closest to the Sun are the 4 terrestrial planets: Mercury, Venus, Earth, and Mars. These are composed primarily of rock and metal and have solid surfaces, few or no moons, and no ring systems. Mercury is the smallest and innermost planet. It has no atmosphere to speak of and experiences the most extreme temperature fluctuations in the solar system, from 800 degrees Fahrenheit 430 degrees Celsius during the day to minus 290 degrees Fahrenheit minus 180 degrees Celsius at night. Despite its size, Mercury has a massive iron core, making it one of the densest planets. Venus is similar in size and structure to Earth but has a toxic atmosphere made up almost entirely of carbon dioxide, with clouds of sulfuric acid. It is the hottest planet, with surface temperatures reaching up to 867 degrees Fahrenheit 464 degrees Celsius. Its thick atmosphere creates a runaway greenhouse effect, trapping heat and making Venus a hostile world. Earth is the third planet from the Sun and the only known object in the universe to harbor life. Its atmosphere, composed mainly of nitrogen and oxygen, and its abundant liquid water make it uniquely habitable. Earth's magnetic field protects it from solar radiation, while its moon stabilizes the axial tilt, creating seasons and contributing to the planet's stability. Mars, often called the Red Planet, has intrigued humanity for centuries. Its surface is dotted with ancient riverbeds, valleys, and the largest volcano in the solar system, Olympus Mons. Though cold and dry today, Mars likely had a thick atmosphere and surface water in its ancient past. Recent missions have discovered water ice beneath the surface and seasonal methane emissions, sparking interest in the possibility of microbial life. 4. The asteroid belt. Relics of creation. Between the orbits of Mars and Jupiter lies the asteroid belt, a region populated with millions of rocky bodies. These remnants are leftovers from the solar system's formation that never coalesced into a planet, largely due to the gravitational influence of nearby Jupiter. The largest object in the asteroid belt is Ceres, a dwarf planet with a diameter of about 590 miles, 950 kilometers. Observations have revealed signs of water ice and potential briny outflows on its surface. Other notable asteroids include Vesta, Pallas, and Hygiea, each with unique compositions and histories. Though often portrayed as densely packed, the asteroid belt is mostly empty space. However, its significance lies in its composition, holding clues to the early solar system's building blocks. 5. Jovian planets, giants of gas and ice. Beyond the asteroid belt lie the 4 Jovian planets, gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. These colossal worlds differ greatly from their rocky counterparts. Jupiter, the largest planet in the solar system, has a diameter of about 88,846 miles, 142,984 kilometers. It has a strong magnetic field, a faint ring system, and more than 90 known moons, including Ganymede, the largest moon in the solar system. Jupiter's atmosphere is composed of hydrogen and helium and hosts the Great Red Spot, a massive storm system that has persisted for centuries. Saturn, known for its magnificent ring system, is the second largest planet. Its rings are made of ice particles, rocky debris, and dust, extending up to 175,000 miles, 282,000 kilometers, in diameter. Saturn has over 80 moons, with Titan being the most intriguing, featuring rivers and lakes of liquid methane and an atmosphere thicker than Earth's. Uranus, an ice giant, rotates on its side at an axial tilt of 98 degrees, likely due to a massive impact in its past. It has 27 known moons and faint rings. Uranus's pale blue color comes from methane in its upper atmosphere, which absorbs red light and reflects blue. Neptune, the outermost planet, is a deep azure world with the fastest winds recorded in the solar system. It has 14 known moons, including Triton, which orbits in the opposite direction of Neptune's rotation, suggesting it may be a captured Kuiper Belt object. Neptune is cold, dynamic, and far more active than once thought. 6. The Kuiper Belt and beyond. The Kuiper Belt lies beyond Neptune's orbit and contains icy remnants from the solar system's formation. This region includes dwarf planets like Pluto, Haumea Makemake, and Eris, as well as countless small bodies. Pluto, once the 9th planet, was reclassified in 2006. Despite its status, Pluto is geologically active. NASA's New Horizons mission revealed mountains of ice, a heart-shaped glacier, and signs of a possible subsurface ocean. Its moon Charon is nearly half its size, and the Pluto-Charon system is sometimes considered a binary dwarf planet. Beyond the Kuiper Belt lies the scattered disk, home to distant and erratic objects like Sedna and 2012 VP-113, which have elongated orbits that hint at the possible existence of a 9th planet, nicknamed Planet 9, still undetected. 7. The Oort Cloud, edge of the Sun's reach. The Oort Cloud is a hypothetical, spherical shell of icy objects surrounding the solar system, extending up to 100,000 astronomical units (AU) from the Sun. It is believed to be the source of long-period comets that occasionally visit the inner solar system. Though unseen, the Oort Cloud marks the boundary where the Sun's gravitational influence fades and interstellar space begins. It's the final frontier of the solar system, a frozen halo of ancient material. 8. What makes our solar system unique compared to other planetary systems? Our solar system's layout is unusually orderly. The separation between rocky and gas planets, the stability of planetary orbits, and the presence of a large moon orbiting a habitable planet are rare features. Jupiter's massive gravitational field acts as a cosmic shield, deflecting potentially hazardous objects away from Earth. The presence of water on Earth, along with plate tectonics and a magnetic field, create ideal conditions for life to evolve and thrive. The solar system is a dynamic laboratory. Each planet, moon, asteroid, and comet holds clues to understanding planetary formation, evolution, and the potential for life elsewhere in the universe. Conclusion: a living, breathing cosmic story. Our solar system isn't just a collection of orbits and objects. It's a living, evolving entity with a past as violent as it is beautiful and a future still unfolding. From the fiery heart of the Sun to the frozen edge of the Oort Cloud, this system continues to inspire exploration and wonder. As missions like James Webb, Perseverance, Artemis, and future probes to Europa and Titan unfold, we'll uncover even more secrets of our solar neighborhood. But perhaps the greatest mystery lies in how all of this came together in just the right way to allow you and me to exist. Thank you for joining us on this journey through space and time. If you enjoyed this exploration, be sure to like, subscribe, and share this video. Until next time, stay curious and keep watching the stars, only here on Mysterious Universe.